Okay, welcome back once again. So as we were just talking about vNUMA and how that relates to a wide VM in terms of its virtual CPUs compared to the physical cores per socket, if a VM has more VM memory than fits within a NUMA node, that's a wide VM as well. However, calculations for fitting and building a vNUMA environment, the memory considerations are not part of that calculation. So for instance, here we have an example where we've got two sockets, 10 cores per socket, and 128 gigabytes of memory per NUMA node with a grand total of 256 gigs on the host, right? If I go and build a VM with, say, 96 gigs of memory and maybe with 8 virtual CPUs, well, that is a VM that can fit just fine within a NUMA node, right? That is not considered a wide VM. And again, even if it had, say, 10 virtual CPUs, even though that's greater than 9 virtual CPUs, that fits within a NUMA node. So that still wouldn't be considered a wide VM if it had just, say, 10 virtual CPUs. But in this case, it's got less virtual CPUs than fits within a NUMA node. It's got less memory than fits within a NUMA node. So it's going to be a single vNUMA node VM. But what if I give this VM 192 gigabytes of memory and it still just has 8 virtual CPUs? That means that from the CPU perspective, the VM fits just fine within a single NUMA node, but its memory is not. The memory will actually have to be split across the NUMA nodes. And the VM will only be told that it's in a uniform memory architecture. If you look at our example, the VM has just one vNUMA node because that's where all of its virtual CPUs are going to be scheduled. So that means that the guest is unaware that some of its memory may be local to its CPUs, and some of its memory is going to be remote because it has 192 gigabytes of memory. And you know what? In the end, that may not be a big deal. The fact that the VM has some memory local and some memory remote without it actually knowing that, right? Because the guest is being presented with what it thinks is a uniform memory architecture. This really all depends on what your application characteristics are. If the application needs to allocate this much memory, that's why you gave the VM 192 gigabytes of memory, right? Because there needs to have a whole lot of memory allocated for the application. But it may not be an application that's actually doing a lot of reading and writing from memory. So the fact that the memory is local or if it's remote may not make a big difference to the application. However, if it is an application that is reading and writing from memory very frequently, then it may benefit the VM to be aware of the fact that some of its memory is local and some of its memory is remote. So what you can do, and you have to be careful, you have to say, this is not, say, the solution for every single scenario, but there's something to consider. You can force the VM to become a wide VM. You have to actually make 2 changes in your configuration. What you'll need to do is actually tell the VM that he's got 4 cores per socket. So you're going into the VM and setting its cores per socket settings. So the VM is going to create 2 vSockets, right? But again, that in itself wouldn't actually, on its own, make the VM be split across NUMA nodes. Another parameter you'd have to set in the VMX file, which is called numa.vcpu.max per machine node. You set that to 4, where you basically are hard setting at the system VM level that there are 4 virtual CPUs in a vNUMA socket. So that's the vNUMA setting. And then you have the cores per socket setting for the guest OS. And make sure those are aligned, right? That the vNUMA and the vSocket are set to the same level, right? We've got 4 cores per vSocket essentially, and we're setting 4 cores per machine node. That's the term we're referring to in a vNUMA node configuration. By doing this, now we're forcing the VM to be a wide VM, not for CPU, but for the case of memory. And again, this isn't necessarily something that you're going to do in every situation, but in looking and troubleshooting and understanding what the application's characteristics are, if it is a case where the guest OS is aware of vNUMA, or I should say the guest is aware of NUMA environments, the guest OS can actually place its memory appropriately where the processes are on the actual virtual CPUs. But if it's an application that just needs to allocate the memory, but may not need to actually read and write from memory that frequently, having set all this up may not make a huge difference. So this is one of those your mileage may vary type of recommendations here. It's really not really a recommendation. It's more of this is an option that is available for the cases that you may need. All right, so vNUMA considerations, right? Always configure your VM's virtual CPU count to reflect as cores per socket, right? You don't want to have anything exceed either the physical core count or total memory for your particular physical NUMA nodes. When you must configure more virtual CPUs than there are physical cores on the NUMA node, or if you assign more memory than a NUMA node contains, you must evenly divide the vCPU count across the minimum number of NUMA nodes. Right, the system will do the vNUMA for the processor part for us automatically, but if you do need to adjust the virtual CPU core socket, the vCPU cores per socket, you're going to also make sure that is evenly divided across the number of cores per sockets at the physical level. And if you enable the hot add function within a VM, right, that's an interesting thing, right? Hot add is great. You can be able to hot add CPUs to your VMs. The thing is, if you've done that, the system can't dynamically just add however many virtual CPUs you're adding to the VM across the different vNUMA nodes. It'll always add it to the first vNUMA node. So basically, vNUMA becomes disabled when you enable hot add. So if you want that feature, just keep in mind that's going to disable vNUMA. It'll make it appear to be one big uniform memory architecture, no matter how many virtual CPUs you have in the VM. So just be careful about that. If you are needing to have that hot add feature, that's the impact with the vNUMA. And there are a whole lot of other vNUMA settings. They're basically not recommending to change them unless you're instructed to do by the Global Support Services folks. So this was a good explanation on how ESXi hosts are NUMA aware. We've explained how vNUMA topology operates and be able to describe how to optimize the number of cores per socket for a VM. And that ends our second lesson. We'll see you in the next one.